Welcome. Can everybody hear me okay? Okay, great. Thanks so much for joining. My name is Emily Tanaka-Delgado. I lead DevRel engagement in Oracle Cloud, and I am joined today by an amazing panel of startup innovators who are all leveraging and taking advantage of the incredible pace of development and access to cloud and open source technologies. Before we dive into that, I'd like to have my panelists please introduce yourselves. Charlie, we'll start with you. If you could tell us a little bit about your company, mission, value, and what inspired you. A little loud?
Yeah. I can just shout. Hello! Hello? Great. Oh, got even louder. Hey, everybody. My name is Charlie Davies from a company called iGeolise. We have developed a product that we call the Travel Time Platform. And what it does is enables the searching of maps and data in the world around us by time instead of distance. So any search that says, what can I do within 1 mile, 5 miles, or 10? We say, what can you do within half an hour by public transport, cycling, walking, driving? And we license this to anyone who essentially makes money through locations online, so real estate products or recruitment products or hotel searching. And we now do this in about 35 different countries. And if you want to play around on it, you just have to go to app.traveltime.me on your phone, and you can play around with the data we have in Barcelona. Thanks.
Great. And?
Ant Kennedy from Gapsquare. So we're a B2B startup building tools for companies to help close their gender, ethnicity, disability, etc. pay gaps. So we're running on Oracle Cloud to enable these businesses to understand how they're paying their employees, if they're paying them fairly. So research from Gartner has shown the future workforce, mainly millennials within the year 2020, care more about transparency and fairness within the company they work for. So we're looking to help them enable this.
Great, thank you. Alfonso?
Yeah, hi, well, I'm Alfonso from ELEM Biotech. Our spin-off is actually a spin-off of the Barcelona Supercomputing Center. On that research center, we have been building for the last 10 or 15 years software that is able to simulate a human heart. So you can have your own MRI and make it a computational model of that and have your own heart beating there. So this is a great research tool, but actually we want to put this tool to the hands of people that can make an impact with that, right? That is the clinicians and the engineers that make, that design the biomedical devices that goes into your heart, for example, right? So we have two problems with this. One of the problems is that these simulations are really complicated to set up. So we have to build this interface that allows to personalize the simulation in an easy way, making transparent for the user all the parameters that are numerical, like, for example, the number of cores or where it's going to run, right? And the other problem that we had that we are tackling with the cloud is the supercomputing power, right? Because these simulations are very computationally expensive, and not everyone has a supercomputer under their desk to run these simulations. So we are using cloud to put this supercomputing power at the fingertips of the people that can actually make use of it and make an impact with this tool that we developed.
Priya?
Hey, so I'm Priya, one of the co-founders of Source Video. We are a cloud-based video creation platform. So we enable brands to create video content with their global communities, powered by our cloud technology and smartphone cameras. So businesses need to create more video than ever today for all kinds of channels and reasons. Typically, they've hired media agencies to produce content or freelancers, which are typically expensive. But there are billions of people that have a smartphone camera device on them. So through our technology, we empower them to co-create with their customers, with their fans of their brands, and with their employees all around the world to create video content.
Great, thank you. And as part of this, now hearing everybody's mission, I'd like to hear a little bit more about how cloud and cloud-native technologies have played a role in building that vision for you. And I know, Alfonso, you already dipped a little bit into it, but maybe you can expand a little bit more for us.
Sure. So we kind of have two missions or two goals that overrun the whole sort of company. The first one is to remove any guesswork from any location-based search. So I'm sure we've all done it, but you do a search for any local content and you see a map and the map gives it context, doesn't give it much meaning around which one's best for you. You might go and then use other applications from the application you're already using to go and understand that further. So we're leveraging lots of transport data and lots of localized information to make sure that when you do those location-based searches, you don't have to go anywhere else from that site. It's all there up front, ready for you to go. And the other one is to get more people to use public transportation or other modes of transport in urban areas to essentially remove the need or use for any emission-producing vehicles. We know that eventually electric vehicles will solve a lot of that problem, but there are problems today that we can solve in terms of moving people around more efficiently, using public transport data, especially in the enterprise market in the countries that we're in. And in the countries element, that there provides one of the biggest problems that we're trying to solve en masse, is this huge amount of data that we have to take in for all these places. So we're not just city-centric, we have to map the entire country for our solution to be as useful as it can be, and also cross-border countries as well. And public transport data, you may think, is really static. It just stays the same, but it doesn't. It changes a lot. I never thought that I'd become a digital train spotter, but that is something that I have actually become. And we take all this data in, and we're having a problem essentially in the machines we were using. Our code base grew up very attached to the revenue we were getting from our early clients. I'm sure we've all been there. When you release the product, clients are using it, your conditions around getting code out change. And we had to move our infrastructure back onto now running Kubernetes in the cloud to change our map processing time down from that, it was up to 2 weeks, now down to a few hours. So we can now take that data, refresh it, make sure it's back out there for our users, as well as use that for testing as well. So the democratization element of actually allowing individuals in our team who aren't that proficient in coding or technical skills can go and take data, spin it up on their own instances, take the tools we've already developed, test that against the environments we have, and then eventually deploy that on their own instances into our production environment.
That's great. And Alfonso, I think you know something about computational time and lots of data. Can you expand a little bit more about the ELEM project as it relates to that?
Me, right?
Alfonso?
Yeah, of course. Yeah. So, as I told you before, these simulations are really expensive. Right. So when you are in a research project, in a research center that works for the public administration, let's say, that's pretty easy to tackle. That's not a problem because you have a supercomputer that is a homogeneous cluster. You don't have to spend money on this, right? So the accessibility to this supercomputing power is like easier because you're part of this, right? Now when you're trying to make an application, a useful application from this research tool, you have to solve that problem. You need to understand how you make this supercomputing power available for the industry. And these type of simulations are computationally expensive. What this means is that we generally, for a generic run, we use like about 200 cores and about 5 hours, 3 hours, depending on the case, right? So when you need to run this outside of the computer, and the cloud is the perfect target for this because it's supercomputing power. You can have supercomputing power that is available without actually having the computer under your desktop or in your place. You only pay when you use it. So it's much more practical and flexible for a business like this, right? So the user of this software is the one that is going to choose when it's going to have the supercomputing power, in which way, how it's going to pay for that. So that's really interesting. And also it's much more flexible than actually the supercomputer that we have on the research center. Why? Because it allows you to run different schemes of different execution frameworks. For example, we can run for larger cases. We tend to run like bare metal instances, but something else that we do is something that we call virtual populations. That's something where we try different configurations on different hearts. It's like populations, or also it's also something like a sensitivity analysis. So in those cases, what we do is we run the executions with containers because it's much more flexible. It is completely independent on the infrastructure or the architecture of the computer you're running. So the cloud basically made this project possible. And what makes is being able to anyone that is interested in running and having the results of such simulations to have the simulations in a short time and being this power available for anyone.
And Priya, for SaaS, I mean, you're doing a lot of computational, maybe not as much as Alfonso's case, but you're still having to do lots of video processing, right, to power that. But also, you've got some AI technologies in the mix to help power that. Can you tell us a little bit about it?
Yeah, absolutely. So, our vision at Source is to really empower businesses to create with their communities. So typically the kinds of users that use our apps and platform are not traditional videographers, they're everyday people, right? So, we use a lot of that technology to make that whole process of creating a video really, really easy. So, over the past few years, we've been capturing a lot of data about how our users are editing their video on their mobile phone. So that's capturing data around where they trim their videos, what kinds of music and filters they add, where they might slow-mo, particular parts. And we're now using that data to actually assist editing. We don't like to call it auto-editing. It's more assisted editing. So we can actually, do some of the heavy lifting when it comes to editing a video. So I don't know if any of you guys have ever edited a video before, but it can take hours if you're sitting at your desktop, tweaking clips. But actually, with our technology, we can use a lot of that data to do that for our user, leaving them with the more creative part of actually building their story.
Which is great, because then you're basically enabling communities to really connect and focus what they really care about versus really worrying about all the back-end technology.
Yeah, exactly.
Right? Yeah. And I think you know something about data and analyzing it all, right?
Yeah, so we started out fairly simple, running everything on a single VM, deploying binaries ourselves, and that was great. The product was very simple at the time, doing some basic analysis over companies' HR data. As the company's grown and as our clients have been getting bigger, we'll be doing more complicated analysis. So we're able to now start to work out which elements of your business are contributing to your pay gap. This obviously takes a little bit longer to compute and leads to a less than ideal user experience using the application. We're also introducing insights into actually explaining where you might have unexplained pay gaps within your company. So say, for example, there's a difference between men and women. Using our machine learning, we can contribute how much pay a woman earns and how much pay a man earns, and is there any unexplained gap in that? So this, the move to cloud native has enabled us to grow and scale the platform massively. So us trying to run that all on a single VM, running that analysis alongside the existing application, alongside actually deploying new machine learning models, new versions of our software, would have been an absolute nightmare. Using platforms like Kubernetes, we can actually start to A/B test these components, deploy new models in a reasonably seamless manner, and enable these insights to our users.
So in terms of that storyline, how important would you say open source is to that?
So open source is absolutely fantastic. I'm generally quite a lazy person. If something already exists, let's go ahead and use it. It's not always fit for purpose, but that's fine. You should be building on the shoulders of giants, and particularly with the cloud native community, absolutely amazing. If you go to any of the projects, people are more than willing to help, which is a huge part in getting any of this done. So back in the day, when we were running on VM, console logs, logging to files, that was it. That's production goes down, we get, the CEO gets an email from the customer, we get an angry email from the CEO, that's less than ideal. Using projects like Prometheus, FluentD, in 30 minutes, if that, we can have logging, aggregated logging, metrics collection, alerting, so the tech team now knows that there's a problem before the CEO, so we can manage it better, as it were.
So those are some of the benefits. What about your team benefits? When they're operating with open source, what do you observe?
So we we've had from a team side an interesting journey. So everybody quite likes to build their own thing and take ownership of that. So using open source, we have taken a few of these projects, little contributions back ourselves, so helping give back to the community. But in terms of our processes, we can now, apologies, we're now moving to more of an end-to-end ownership ourselves. So keeping rapid deployment, like these open source projects, Kubernetes, fairly regular release cycle, sometimes difficult to keep up. But we've taken this mentality in-house. So we've moved to continuous deployment. So we're getting our software updates out to our customers as quickly as possible. And hopefully they're enjoying the benefits sooner rather than perhaps a more delayed release cycle that we were using previously.
That's great. And Alfonso, you're coming from the supercomputer background, that open source platform that you've been extending, I mean, it basically started all in open source, right? Even if it's a little bit different from Kubernetes, that's really where the heart of it was.
Of course, yeah. Open source software is like transversal to and absolutely necessary in every research area when you're doing like research, right? Because you run in Linux clusters, you use open source visualization tools, you use a lot of open source tools to do that. So for us, that natural environment has like moved naturally to the company we are in. So open source software is like everywhere. Probably like 90% of the software that we use is open source, right? Even our own source code is open source. So it's transversal, and I mean this type of way of working is also in everyone, on the company and on the research center. This is very natural. Sharing your work, helping others to do something better with the tool you got, right? And that makes you proud, like helping someone else with something that you have done. That's really nice, and that's open source mentality is like in everyone in the research center and in the company too. So that's the idea, helping others, right, with the things you do.
Absolutely. And in your case, trying to use the tool, you're using open source, but you're also providing a tool that you're guiding your users so that they can access it and leverage the power of it, but maybe not know every single thing about it, right? Not go through the research that you've already done, but really help to curate that for them to be able to do what they need to do.
Yeah, in our case, the final tool that we are doing, it's the thing with open source is that you sometimes need the source. Not everyone needs the source. Some people just need the executable file, the compiler, right? But in some cases they do, because they want to know what you're doing and they want to maybe make their modifications on that software to make it fit it to their applications. So that's what we are targeting. I mean, and of course, there is a lot of support from our side for the people that want to use our code.
Right. And Priya, what about you? What do you think about open source as it relates to SaaS?
Yeah, I think one of the things that always strikes me is when we bring customers and clients to our office to, for a meeting or to meet with us, they're really surprised that we're a team of 8 people. They're like, wow, how do you build all of this? How do you manage this? We have global clients like Accenture and Oracle and Premier League football teams, and they're amazed. And I think, because we have access to use all these technologies that are in the cloud, we can manage our customers, we can manage heavy loads of videos that are getting uploaded to our platform, and we can really focus on building incredible kind of technology for our customers, for the end user. So taking that, that strain and off our development team, they can really focus then on building features and things that our customers really want to use and improving our platform on that side. So yeah, I think it's been really great.
That's great. And I think the extension value there is huge for open source. I mean, this conference is a testament to that, right? It's tons and tons of people. Yeah. And that means that we all get basically that amplification just by participating and talking to other people, learning what they're doing, learning what went wrong, right? Learning what the surprises were. And that really helps us all move forward at a much faster pace, which is part of the whole benefit, right? And I think that's kind of a nice segue just to kind of dip into, were there any major surprises or things that you kind of encountered that you can teach other people about how you recovered from it, or things that were aha moments for you in terms of open source or cloud or any other part of your journey as a startup?
So our open source, I don't think any of us would be here unless open source really existed. We use open source in a number of different ways, whether it's down to the libraries we use in geospatial technologies, or even down to the data that we take in. A lot of data we use, for example, like OpenStreetMap is freely available to use, even commercially, but it's not always completely correct. So we do a lot of work by taking that data, cleaning it, and then giving it back straight to the community, or even the public transport agencies that we work with. The one time that I've got in my mind about open source being a big problem was when we sat down with a lawyer from a bank, and we were deploying our technology with a bank in the UK, and they just didn't get what open source was. They wanted to read every single license through and through and through. One of them said, if you ever meet me, you can buy me a beer. And they were worried that if they used it that many times, how many beers they would actually have to buy the guy who wrote the license on the README file on that GitHub repository. So sometimes it's more the education around other people not understanding completely what open source is and how it works, especially in the commercial environment when people really, well, it's their job to make sure that, especially for the bank, had to tie everything down. And also, just because it's open source and free doesn't mean it's completely the right decision. We have to make sure that we're using tools that accelerate what we're trying to do right now. When we started, there was a big thing around when I was actually coding everything. It was, how can we do everything without spending any money at all? And there were lots of open source libraries we could use. Some of them we use now are actually proprietary because they are accelerating what we can do ahead of time. But now all of our developers spend 20% of their time contributing back to open source projects, whether that's on the data side or the programming language we use, or right down to the libraries we use as well.
That's great. What about total impact? For everything we've talked about, from open source to cloud native technologies, what do you see across impact for your company, your customers, even your team, right? We've talked a little bit about it, but maybe some of you, and maybe there's some things you'd like to expand on.
So in terms of what cloud actually offers to Gapsquare is a platform where we're able to start relying on other people to do the work for us. So there's many managed services out there that we're making great use of and avoiding doing the hard things ourselves. So if we weren't able to rely on those, we would have to bring that talent in-house, so spend more money on recruitment, less money building features of the tool, more money managing updates, etc. And it's if you can, ship all the hard stuff to someone else. It's going to make your life easier in the long run. If you've got to bring it in-house, open source is great. There's, for example, all the great databases people use. There's Helm charts to go deploy them in Kubernetes. The communities are super great in terms of forums available. It's definitely the future, and hopefully it stays this way.
That's great. Alfonso, did you have something?
Yeah. Can I also answer a question
Absolutely.
you made to Charlie?
Please do.
Okay.
Score, right, guys?
Okay. So we had like two big aha moments that changed a lot the input we were having. The philosophy behind those aha moments is clear, and everybody will say, yes, of course, that's true. But it's really very hard to understand what you're doing, right? So one of the aha moments is that we work with results that should be understood by clinicians and physicians, right? So the thing is that if you show them the results that you are used to get and the way you see it yourself, and you feed with that to the clinicians, they won't get it. It's just like that, they won't get it. The same results we show to them in the slices that they were used to see, and the sequence and the organization of the image that they were used to see. And in that moment, they started saying, oh, right, a human heart. Yeah, I see how it moves. I see the different strains, and see they started seeing everything. So what is the story behind this? It is that we didn't understood that we had to feed the client, quoting, what they wanted to be fed, right? So we were trying to feed them what we are used to to get from our results. So this, you can extrapolate this to everything. You cannot like put a dish in front of your client and saying, hey, eat this because I made it, right? You have to sell that thing in a way that they feel appealing, right? That's one of the aha moments. And the other one was actually the reason why the startup was created. We were doing a lot of consultories with big companies, like getting results for them. And at one point they were like, okay, but now I want to run the case by myself, right? And I went there for like 3 months trying to teach them how to use the code, but it's of course a very complex code. It's like 1.5 million lines, on Fortran, whatever. Nobody can understand it, of course, not even us. But in that moment, we said, hey, okay, we need to do something that these people can use, right? We cannot do that in the research center for the state, right? Because that's not something, that's not research that is going to lead to increase of knowledge. That's research or work that is going to lead to increase the welfare of the world by making this tool available for who needs that, right? But in that moment is when we said, okay, how do we do this? Well, we have to create a company. So that's the other aha moment we had.
Priya, do you have any aha moments or teachable moments or anything that you think would be useful for our folks here to learn from you?
I think, yeah, just going back to, you know, being able to cope with a growing platform. You know, we're quite an ambitious company, and sometimes we take on more than we can probably handle.
As a good startup should, really.
Yeah. But, you know, for example, Manchester City is one of our customers, and they have match days, and they get all their fans around the world to kind of contribute and upload their videos of where they're enjoying the match. And I think, you know, we kind of go for it with what we're doing. And we, you know, we're a startup. We expect things are going to fail. But I think sometimes we surprise ourselves with how much, you know, how much Kubernetes and things can help us scale at those critical moments where you think it might fail, but it actually helps. And you know, we've had several of those moments where we've taken on stuff and it's worked. And I think that has just been really positive, and we embrace technology even more, especially cloud technology, when those moments happen, and you come back and you're like, wow, this thing like really freaking worked. So.
Which is a great moment to realize something works, right? We're pretty happy when that happens. Yeah, and in fact, some of these things really just couldn't have happened, you know, even a few years ago, in terms of the pace of technology and where even cloud was a few years ago. And I think those moments of scale, Charlie, I know you had some of those moments of trying to scope, okay, we've got, you know, right, 33 plus or right countries that we're trying to process all these maps across the globe and produce real-time results, right, which is a big ask.
Yeah, I mean, my first demo that I ever did to someone of meaning in terms of the big contract for the company, our demo took so long I had to distract him enough while talking to him that when he turned around the results were on the screen. And I got really good at that because the system was really bad. I built it, luckily I've got far more intelligent people working for us now. And then recently we launched a service that is able to take 100,000 locations, rank and sort those and deliver them back to the client in under 250 milliseconds, including the network transfer time. There is no way that we could have done that 10 years ago, maybe even 5 years ago, in terms of the availability and cost of the units that we're using. So the real scale of that we can take and then make sure that those searches can happen in the same response time if you're in Sydney, if you're in San Francisco, or even in Santiago in Chile. Anything like that would not be possible at the moment without the decisions that we've made on the system architecture side and how we've scaled that up. And we know, we know very well when that limit is going to get reached in our current architecture. If we reach that point, maybe we won't care. But we do know at the moment the designs that we put in do have limitations in terms of the scale, the concurrency rates, the overall network capabilities. Hopefully there'll be technologies in the future that can help us out as we scale that as well.
Any other thoughts on, you know, future areas that you're hoping to see development or places that you're hoping that you can contribute in either your businesses or open source or cloud?
Sure. Yeah, so we're very much looking forward to where we can take the machine learning side of our business. So given the availability and the democratization of AI, there's so many open source projects out there that will do these cool little jobs for you. And it's now, given the state of containerization, it's very easy for us to go build a container, deploy it, stick an API in front, and great, we've got a new feature in the tool that we can start selling to customers. I admit it's not quite as easy as that, but we can very much sell it and build proof of concepts a lot quicker. Refining takes a lot longer. But it's, again, this would not have been possible even 5 years ago. We look at the state of machine learning back then, it's all sorry, this state of machine learning back then and the state of machine learning now, the amount of compute resources, particularly around deep learning techniques, it's way outside the scope what any small, tiny company would have been able to do back then.
Yeah, for us, the main reason that made us this company possible was not that much the computer power, because we had the computer power, but the possibility to have this supercomputing power available for anyone, right? Mm-hmm. Thanks to that, we can build a company that can make a software that can be used by anyone, because our application requires supercomputing power. That wasn't possible before, not 5 years ago, as he says, right? And for us, the target in the next maybe 5-10 years is that this tool reaches, now we are targeting like engineers for medical devices companies, because that's the more specialized people, that's the people that is like generally more in touch with simulations, right? But at some point we would like to move towards clinicians. And imagine this future, close, near future, that you go to your clinician and you go there and he gets your MRI, right? And you have an infarct. And you can put that MRI on the software and you get a simulation of your infarcted heart, right? And the clinician can try on that computer what is the best treatment for you, what is the best pacemaker, what is the best location for a pacemaker, before you get even in the surgery room. And then when you move to the surgery room, you already know what is the most efficient treatment for you, right? Because this is another problem. We all think, at least I thought, that if you get a pacemaker, it's going to work. I mean, everybody that gets a pacemaker thinks the thing that he has inside it is going to work, right? That's not the case on every time, right? Today, people that, these are very specific terms, but people that have left ventricle branch block, 40% of the patients that get a pacemaker, the pacemaker is useless. It's not working properly. Because the pathology is not responding to the pacemaker. So with this type of software, what we want to do is improve these rates. Get a pacemaker if you need a pacemaker. Get the most optimal configuration of your pacemaker for you. Get the best pacemaker for your pathology. So that's what we aim in 10 years.
It's a good vision.
So cool.
Yeah. Priya, do you have some closing words of wisdom for our friends here?
Yeah, that's for sure. You know, I think putting my sales and marketing hat on, for me, it's all about creating a great product that people want to use. Ultimately, people need to use, you know, the technology that you're developing for you to be a viable business, right? And so these technologies are great, and there's a lot out there. But at the end of the day, it's about knowing what you need, because there's lots. You can build, there's lots of tools available. But it's really about, for us as a team, and I think as our culture, is how is this going to affect our clients and our users? How is it going to improve you know, what they do? How is it going to enable them to create video better, faster, cheaper? So, you know, I think it all comes down to kind of working together with product teams, with sales teams, and understanding the pure use case and why are we building this? Like, will it make our technology faster, or what is it that you're building? So I think that's really important, and we kind of really believe in that and working together as a team when we're talking about these technologies and choosing what to use.
Great. Thank you so much. I think that brings us to a close. I want to thank our panelists and our guests. If you'd like to continue the conversation, please come to the Oracle booth and you can talk to these lovely folks. Thanks so much.
Thanks, Emily. Thank you.
Cheers.
Bye-bye.